Okay, very good morning to everyone. Good morning to everyone. Okay, so in last time we have discussed about the series circuit and parallel circuit. Okay, so today we are going to start the symbolic representation of electrical components. Just like in the maps, we used some symbols to represent some of the things, just like a temple, mosque, railway line. Okay, in the same way, in the circuit, we use some representation for different electrical components. Just starting with the first one, conducting wire. Conducting wire from which current flows. Wait a second. Conducting wire. So conducting wire is represented by straight line. So conducting wire is represented by straight line, and it is usually made up of copper because copper is a conductor and it allows to pass charge, or we can say it allows to pass electricity. So it is represented by straight line. So this is symbolic representation of conducting wire, and it is insulated with cotton, or we can say plastic cover. Okay, so in electric iron, some of the electric iron, old electric iron, you can see the wire is covered with the insulated of cotton. Okay, cotton insulated wire. And the second thing is resistor. Okay, and we have discussed about the resistor, which resistor, or we can say resistance. Okay, resistance is a property and resistor is a material. Okay, so resistor is a component of a circuit which opposes the flow of current, which hinders the flow of current. Okay, which stops the flow of current. So it is represented by the zigzag line. Okay, so if this zigzag line is present in the electrical circuit, so it represents a fixed resistance, okay, or we can say constant resistance. So this is for fixed. And can anyone tell, we have discussed it, anyone tell the representation for the variable resistor? Anyone know how to represent the variable resistor? Okay, Utsav. Okay, Utsav, answer.
Sir, there will be a mark.
Sorry, can you repeat?
Mark.
Just repeat.
Sir, slanting mark on.
Okay.
Sir, slanting mark on the fixed width.
Okay. Okay, Sadhgi, your answer?
So there will be an arrow mark.
Okay, arrow mark. That is correct. Okay, and this we have discussed in the. Okay, fine. This we have discussed in the topic Oersted experiment. Whenever we decrease the resistance, there is a variable resistance present in a circuit. So this is for variable resistance. So this is variable. Variable means we can change the value of resistance for this. Okay. Now you can put your hands down if you have no doubt. So, you have any doubt? No. Okay. Ishika Raj?
Good afternoon. Morning, sir.
Good morning.
Sir, when you will send a physics chapters PDF question answer?
Physics chapter PDF 7.1 or 7.2?
Sir, 7.1.
Okay, that I have shared. Okay, so I think in your group it is not shared. So I will share it. Okay.
Okay, sir.
Yes, Ankita.
Sir, what is the meaning of negligible?
Negligible means you can say about zero. Negligible means zero,
Okay.
approximate to zero. So it is given that resistance of conducting wire is considered to be practically negligible. Means we consider there is no resistance in a conducting wire, but it is not true. Means there is a resistance in everything. Every material have resistance. Okay. Now Ishika, if you have no doubt, you can put your hands down. So this is all about the symbolic representation of the conducting wire, resistor that is fixed, and with the arrow variable. Okay. Now, the resistance wire is generally made from metallic alloys such as nichrome that is used in electric iron, eureka, constantin, manganese, tungsten. See, nichrome is used in electric iron, tungsten is used in electric bulb. And your homework is you find out the uses of this eureka and constantin and manganese in which of the electrical appliances, because it is highly resistant material. Now, about the cell. Cell is the source of electricity. Now, how we represent cell? Many times we have discussed to represent the cell. Two bars, one is long and one is short. The long bar, yeah, long line will show the positive terminal of the cell, and this small line will be negative terminal of the cell. Okay. Now, and this short bar is thick one, and this is thin and long. This is thick and short. Okay. Battery. Yesterday I told you battery combination of two or more cells is called battery. And how to represent the battery? Battery is also connected in two ways. As in resistance we have as in circuit we have discussed now, parallel circuit and series circuit. Electric cell is also connected in two ways, just parallel and series. Just see, if we connect like this, so this is series combination of electric cell. Series combination of electric cell. Positive terminal, negative, positive, negative, positive, negative. Same way, the negative terminal of the first cell is connected to the positive terminal of second cell. Then again, the negative terminal of second cell is connected to the positive terminal of third cell. Means alternative terminal, plus minus plus minus plus minus. Okay, so this is series combination. And in this also, if any of the battery will not work, the whole circuit will break. Suppose this second cell is not working, what happened? Current will not flow, the series will be broken, the series will be said to be open series, open circuit. Okay. Now the parallel combination of the cells. Positive, negative, positive, negative, positive. So each positive terminal of cell is connected to the another positive terminal of the cell. You can see positive connected to positive, connected to positive, negative connected to the second negative, and the second negative connected to the third negative. Okay, so this is the parallel combination of cell. Okay, now if any of the cell is not working, it will not affect the circuit. If any of the cell is not working, suppose there are three cells, 1 2 3, and suppose first cell is not working, what happened? Other two cell will be working, and the circuit will be in the closed circuit and current will flow. Yes, Arya Pratap.
Sir, where it is used parallel cell?
Sorry.
Sir, parallel cell where used?
See, parallel circuit, parallel cell is used where we have to we require less voltage. Okay, can you hear me?
Yes, sir.
Okay, so in higher classes when you study, if two cells are connected, so the combined voltage of the cell is IR1 plus IR2 upon R1 plus R2. Okay, this is a long derivation. Okay, just listen for this. your purpose that if we are using series circuit, suppose 3-volt battery, 3-volt battery, 3-volt battery, what will be resultant? 9 volt. Here, if we connect the cell in series, we get high voltage. But if we connect the batteries in a parallel combination, what happened? We will get less voltage. Suppose for a small device, charger or something like this. So the adapter is made in such a way it consumes less voltage. Okay. So for requirement of less voltage, the cells are connected in a parallel series, parallel circuit. Okay. Now key is just like a switch. Okay, a plug key or a single key in an electric switch. Now symbolic representation of key. This arrow join means this is closed circuit. Current will flow. Switch closed for the closed circuit, and this is open for the current. Not flow, will not flow, and here current will flow. Okay. So this is open plug key. We can say open plug key. And this is closed plug key. Same closed plug key. So it is a representation of plug key for open and for closed one. Now bulb. So the last symbolic representation of bulb, electric bulb. This is the two terminals of bulb. One is positive and another is negative, and it is enclosed in a circle. So this is the symbolic representation of electric bulb. We can say. Okay. So it is a very easy topic, the symbolic representation. You just have to do practice. Okay. Now coming on the next topic, good and bad conductor. I think you all are familiar with the good and bad conductor. Okay, good conductor means conductor, but bad conductor we name for a bad conductor, that is insulator. Okay, so good conductor conduct electricity. Okay, because and also good conductor conducts heat. If we are talking about the chapter heat, but here we are discussing about the electricity. So here we will consider conductor means which conduct electricity, and insulator means which does not conduct electricity. So if the cell is connected to bulb by brass or aluminum wire, the bulb glow. It is because the brass or aluminum wires allow the electric current to flow through them. So why we use copper wires, aluminum wires for wiring or for the making electric circuit? Because it is a conductor. Conductor means it allows to pass the current to flow through it. Yes, also.
Sir, what causes the current to flow in impure water?
Impure water. Okay, just hold on. I will explain it. Okay.
Okay, sir.
So first we are discussing about that conductor which allow the current to pass through it, and the bad conductor, or we can say insulator, which does not allow to pass through it. If we are making electrical circuit, suppose if we are making electric circuit, you all are familiar with the simple electric circuit that is made up of conducting wire, a bulb, cell, switch. Okay, suppose this conducting wire is made up of plastic, or we can say rubber. What happened? Current will not flow because rubber does not allow to pass to current through it. So rubber will be considered as a bad conductor. Okay, so for flowing of current, it is necessary that conducting wire should allow the current to pass through it. Means it should be conductor. Okay, now examples of good conductor: silver, copper. Others, I can't unmute you. I don't know why, because there have Network issue or what? You have raised your hand, but I can't unmute you because I think you have a network issue. So coming on the topic, the next thing, examples of good conductor. Silver. Yes, Naman Mishra.
Yes,
Naman
sir.
Mishra. What happened?
Yes, sir.
You have any doubt? Okay. So examples of good conductor are silver, copper, aluminium, gold, iron, brass, tin, steel, lead, impure water. Okay. Impure water, human body. We also get shock because whenever we touch electric circuit or flowing current, what happens? We get shock. So our body is also a conductor of electricity. This animals, living plants, all are conductor. Now coming on the point, how impure water is a conductor of electricity. I'm getting on it. And first thing, silver is the best conductor, but it is not used in electric wire because it is very costly. So in place of silver, we prefer copper to use in a electric wire, use in electric wire, making electric wires. Okay. Now impure water. So in higher classes, you will come to know that current also flows uh, uh, through the moving ions. So you all know about the ions. Okay. In chemistry, you have learned ions, cation, and anion. Okay. Suppose salt NaCl. So in impure water, just like a sea water, take example of sea water. So what happened? There is a just hold on, Ansh. Okay, I'm just coming on you. Just let me complete this. So in sea water, what happened? Or impure water, there are some dissolved particles. So in water, what happened? It dissociates, it breaks down, and it breaks down in a ions. Suppose NaCl is present in impure water. So what happened? NaCl will be break or dissociate into Na plus and Cl minus. Na plus will be cation and Cl minus will be anion. And this cation anion will be act as a charge particle. Means if it move, it will conduct charge and it will be means the whole water, impure water will be acting as a conductor of electricity. So due to the presence of ions, the impure water acts as a conductor of electricity. Okay. Now Ansh, you can raise your hand. So if you have any doubt. Yes, Ansh.
So will our exam will be held on 10 February?
That I don't know. Okay. Yes, Ankita.
Sir, where does the open plug key is used?
Open plug key. Suppose we don't want to conduct electricity, so we open the switch, off the switch. Okay, open plug key. And if you want to conduct electricity, suppose in that experiment, Oersted experiment. Okay, we want to see the deflection. When we want to see the deflection, we close the switch. Means the current will flow.
Yes.
Again, if we open the switch, current will not flow. In the same way, if you are making electromagnet, we want to make an electromagnet. What happened if we close the switch? The solenoid will act as electromagnet. As we open the switch, what happened? It will again act like a, or it will demagnetize. Fine.
Yes. Yes.
Now, it is given in the third para, 1, 2, 3, fourth para. Connect to the cell by a cotton thread or rubber band instead of copper wire. So just now I have explained you, if you use cotton wire, rubber, what happened? The current will not flow because it is a bad conductor of electricity. It does not allow to pass the current through it. Now points to remember. The electric circuit flows through a circuit only if circuit is closed. See, if the circuit is closed means closed plug key. Key should be closed. Okay. As the circuit is closed, the current will flow. And every part of the circuit should be conductor. Conductor means which allow electricity to pass through it. Okay. So the two things we have to remember. The circuit should be closed and every part of the circuit should be conductor. If any one of the condition is not satisfied, current will not flow, and if you connect the bulb in the circuit, bulb will not flow. Now the material which does not allow the electric current to flow through them is called bad conductor or insulator. The same thing we have discussed from the beginning. Okay, examples of bad conductor is plastic, nylon, bakelite. That bakelite, this question come in a any Olympiad. So it is option that bakelite is the first synthetic plastic. You can, if you want to note down, you can note down bakelite is first synthetic plastic. First synthetic plastic, and it is insulator. Okay, first synthetic plastic, and it is also called material of thousand uses. It is also called material of thousand uses. Because it is used in various purposes. It have wide application. Now rubber, cotton, polythene, glass, ebonite, flax, these are bad conductor, or we can say insulator. Pure water doesn't have any ions. Pure water or distilled water, it don't have any ions, so it will be act as a bad conductor of electricity. Okay, and ebonite is a hard rubber. Okay, and seawater and impure water will be good conductor of electricity. Now we have discussed about yesterday we have discussed about the calculation of resistance in parallel circuit and in series circuit. Okay, so just now you solve this question. Take out your copy and solve this question. If one resistance R1 is equals to 5 ohm and R2 is equals to 3 ohm, first it is connected in series. Okay, first it is connected in series. In second case, it is connected in parallel combination. You have to calculate the equivalent resistance or total resistance for it, series and parallel. Okay, raise your hand if you have calculated both for the both. Okay, answer.
Sir, in series it will be 4 ohm.
In series,
And
what will
in
be the answer?
parallel,
Just
4 ohm.
speak loudly.
4 ohm.
4 ohm in series. This is 5 and this is 3.
Yes.
Okay, anyone else? In series, you have to simply add it. It is very simple. Okay. Yes. Sadhiki.
Sir, in series it will be 8 ohm
Hmm?
and in parallel it will be 1/8.
1 upon 8. 1 upon. Okay, just check your answer for the parallel combination. Aditya.
Good afternoon, sir.
Good morning.
Sir, in series it will be 8 ohm.
Parallel.
And sir, in parallel, sir, 1/8.
Okay. Sadhgi, you have calculated answer, correct answer. Or same answer. Okay. See here. For the series, 5 plus 3, which will be equal to 8 ohm. For parallel, the formula is R total, or we can say R equivalent, equals to 1 upon R1 plus 1 upon R2. Okay. I'm taking 1 upon R total is equals to 1 upon R1 plus 1 upon R2. 1 upon 5, first one, 1 upon 3. LCM of 5, 3, 15. 5, 3 is 15, 3, 5. Okay, 1 upon R total. So 1 upon R total is will be equal to 5 plus 3, 8 by 15. And here it is the value of 1 upon RT. Now we want to calculate R equivalent, means we have to reciprocate the value. So RT will be equals to 15 by 8 and with unit ohm. Yes, what happened, Aditya? Okay, so for now the time is over. So thank you. Bye.